All right, guys, this is the second breakout room for EIP-4444s. I have some things on the agenda here that we can discuss. I'll post the link in the chat here. But I don't know, we only have about 30 minutes. I have to go to a call at the top of the hour. People are free to stay on afterwards. But this is like roughly the things that I've been thinking about. I don't know if other people have like other specific things to talk about. Sorry, let me post the link again for them because they're asking for the passcode. Okay. Does anybody have something that they want to discuss before we talk about like this roadmap, the rough idea, and then talk about answer these questions?
I feel like we should start all these meetings with a discussion about how to pronounce EIP 4444.
I'm pretty sad because Vitalik pronounced it on the whatever podcast he was on like last week, EIP-4444. And nice. I feel like that's just really hurting the branding of the and I don't know how we're going to be able.
Is what he's doing.
I'm still team 4-4s, Matt. Don't worry.
Yeah, I mean, it's just important that we're all on the same page with this, because if we can't even be on the same page how to pronounce it, there's literally no chance that we're gonna be able to ship this to mainnet. Wow, that is an incredible mustache.
Yeah. Oh my God.
Holy
welcome,
shit.
Welcome Alex's mustache. The call.
Hello, everyone.
Hello, Alex. I was just saying that I posted this agenda. I basically have this roadmap, which we've kind of like roughly talked about in the past, and some questions. I don't know if there are other specific things that people haven't added there that they want to talk about, but if not, we can just talk about this roadmap and then answer those questions.
Where is it?
Oh, so let me post the link again. It's on the, that's not the link. It's on the GitHub agenda.
There's a GitHub agenda. Wow. PM issues 545. Okay, I'll go find it.
I sent it on Zoom.
Thanks.
Okay. So in my mind, I think this is like roughly what Proto had talked about in one of the first meetings that we had is, we need to define this SSE object that's going to contain the RLP block bodies. We need to then implement some sort of mechanism in the execution clients to verify those SSE objects and also create them, and then actually import and execute them so that you can get to the latest state with the historical data. And then like farther along is we need to talk about how we're going to distribute the data over BitTorrent. Like, are we going to have a client that kind of, uses some sort of BitTorrent library, or is this going to be more on the user's end to just take that file and seed it themselves, or connect some sort of magnet link and then download and seed it themselves? And then the final thing is like to actually implement 4.4s, which I think we're, pretty far away from doing right now, since it's not something that I think is going to be accepted into a client for at least 6 months. So if we do implement it now, we'll just have to keep rebasing it against changes for clients. So that's kind of roughly what I see as like a roadmap. I don't know if you guys thoughts on that.
So the question I have is, how confident are you that this is like what we need to do? Like, have we validated that like if we do this thing, then everyone will accept what we're trying to do and it will all be good and happy?
Roto?
I'm sure it would be nice if we knew that what we were building was going to be used before we built it.
Well, because like there was like more, I think, philosophical pushback from like example the Geth team. So the question's like, is there stuff we can do? Because we can go and build on this. Like that's not really a problem. Like
For sure.
Everyone here is very capable to do that.
The
question is like,
on this? I thought they said
general
that they would
pushback
just
has
be,
been
yeah.
The general pushback has been that BitTorrent is not as a distributed store of information as they would like.
I think the more I think, I mean, that is Marius's position, but I think we can argue him out of that if I can convince him to sit down with me for an hour. I think the bigger pushback from the Geth team, I'm confident. I think the bigger pushback from the Geth team is that they don't want, the impression I got is they don't want it to be something that is not in the client. Like they want the Geth client, if I understand correctly, someone else may be able to correct me here. They want the Geth client to be able to do it, which means if we do BitTorrent, they want the torrent, capabilities within the Geth client. And that's where things get hard. It's much easier if we can, yeah, so it's much easier if we can, download it via BitTorrent and then just import it into the client. But I think they wanted, a one monolithic thing. And
Didn't Marius had some milestone that if we hit that milestone, then he thought it'd be okay to drop it? I forgot what it was. If anyone remembers, I don't know.
We're getting a little bit ahead of ourselves here with how the solution should look like. We should look at how we want to deploy and how we get there. And I believe like even in this issue where we define this difference between SSE and RLP, in the end, there is these subcomponents that we should just give people ownership over and not try and prioritize over just the bigger thing.
So I think Henry is planning to spend some time specifically on the first two steps. I think you've looked into SSD a little bit, and I think my understanding was at some point you would come up with, say, this is what I think the actual definition of the SSD object should be. And we can talk about and make sure that that's like what we all are sort of assuming. Like, I think we all sort of think that this is going to be some sort of SSD list that has, RLP data on the leaves. There's like some small questions about should we serialize both the block and the block body, the uncles and the transactions together, or should they be separate? And then after that, after we agree on that, I think Henry is also going to implement this into an execution client to do the verification, the import, and the export. So the rest of us are really not doing anything.
Yeah, that's kind of my idea. And by the way, for those, I know I've met some of you on a recent call, but for those I haven't, I'm kind of new to this whole thing. I'm relatively recent convert and working, looking to get into working on Ethereum. I've done a bunch of database stuff previous to that. And so having worked with Tim, he suggested that I could help out on implementing some of this as a nice way into Ethereum development as a background. But yeah, to what you were saying, that's my understanding. I think, and that's what I intend to get started with. The two first items, it sounds like, unless there's some, it sounds like we can get going with those two without having to settle the broader question of of the BitTorrent and of the distribution mechanism and whether or not that's integrated into clients and all of that.
For sure. That's something that we should do in parallel.
Yeah. I have a few implementation related open questions, etc. I don't know if we want to get into that now or later, but kind of
let's choose. I'm happy to just start talking about implementation specific questions on step one.
Okay. Yeah, so well, you just the outline that you had is more or less what I was thinking, and I think what we discussed last time. I guess, well, one of the questions I had, so I started looking at this more seriously last week and this week a little bit, getting into SSE. And one question, which I need to figure out pretty soon, that's kind of related to number two, is which execution client would be the best candidate for this. And the reason I'm interested in that is there's a bunch of SSE implementations in different languages, and I've kind of looked a little bit at the fast SSE in Go, and I know there's a Python one. I don't know if there's a kind of natural, obvious, good candidate for the execution client to use for the proof of concept or not, but that would be helpful.
Yeah, usually Geth is the preferred one.
Okay.
If
so
you're comfortable with.
Geth is the preferred one, I would say, because it is dominant, but we're really trying to make it not the dominant client. Like the way Ethereum works, we don't want a dominant client. We specifically want people to use other things. And so people use Geth because Geth is what they know. And so if you know nothing, I would weekly encourage doing something else, like any other client, just to kind of just incentivize more growth out into other places. Again, if Go is your favorite language though, then Geth is a good choice. If C# is your favorite language, never mind. If you really love Java, then maybe you can work with the Besu team.
Probably Go, but in that case, so would Aragon be a good choice, or that's probably not the easiest one to get, right?
It's harder to work with them sometimes to get things upstreamed.
Okay.
That's my experience. I mean, not that it's necessarily easy for Geth, but slightly harder with Aragon.
Okay, well, Geth was what I was thinking as the default choice, so it sounds like that kind of confirms. But I mean, given that, if Go, I'm way more productive right now in Go than.
If you've got a language preference, I would just go with language
so.
preference.
I think
that's what makes the most sense
Geth is a
usually.
good choice then.
Just in chat, I shared a list of libraries. We
Yeah, I've
track
seen
all the
that. That's great.
implementations. So just browse that and you'll find something to work with.
Yeah.
That said, I've worked with SSE before. I have a few implementations, but I'm not necessarily saying you should use SSE at all. Like, what are we really trying to achieve? Do we want some kind of proof to be accessible, or do we want some kind of serialization property? These things are not specified right now, so maybe we should do that first.
Yeah, this is one of the main questions that I had, and I think the strongest proponent for SSE was actually Piper when we originally spoke. And it I think, like, for me, the two main reasons to go with SSE is, number one, SSE is sort of the next generation serialization format, and I think that the more new things that we do in SSE, the easier it will be to transition over time everything to SSE, even if that takes a long time. So I think that is in itself a pretty strong reason to go that direction. And the other reason is that if we are going to basically be creating these checkpoints that are creating large segments of blocks that we're committing to, then we can now prove something about a historical block. And we don't really have that functionality in Ethereum right now. This is like something that will be out of the protocol, but we will have a way where, similar to having like a weak subjectivity checkpoint where we say, this is something I trust, I can now say, I trust this root, and now I can prove something about a historical block. So that kind of gives us more functionality. The thing is that there's not a lot of people who are requesting that functionality. There are people who want to have it in the protocol in a smart contract context, but I don't think that this will be like easily, like, maybe we can have a smart contract where we post these roots to, like, they are, checkpoints, and you can like sort of prove them, but they're not something that you're, ascertaining from the protocol itself. So there's like a weaker guarantee there. So to me, those are the two reasons to go with SSD. I don't know if there are other reasons that people have, or if there are reasons that people have to not go with SSD.
I think the reasons you gave are the exact reasons I was going to give. Just to play devil's advocate a little bit, reason for going with RLP is just because that's what everything today uses, and so integration is going to be a little faster and easier. Like, if you don't, convert the blocks all to SSE, you just have them in RLP. We already have them all in RLP. So when you import them into Geth, it's just a direct, hey, Geth, here's the block as you understand it. You don't have to convert between the two. Fairly minor, I think, in the grand scheme of things. And I agree with Matt overall. I think that's the argument.
Well, I guess there is like this one, specific point that the leaves of this SSE object are still RLP encoded. That was one decision that we had made to avoid exactly what you're saying, where now you have to define the SSE spec for every block, all historical types of blocks, and the clients have to support the manipulation of the SSE object into the RLP object. Whereas if we just commit to the SSE list, we do get a lot of the functionality of being able to prove things about historical blocks. We don't have the granularity of being able to prove a specific thing in a block. We have to prove the whole block. but we
Like you can't
still,
prove down into like the nonce, but maybe you could
Yeah.
prove down into like the header as an opaque RLP thing.
yeah, I can't like easily create a proof against some specific value of the block. I can create a proof to the block, but I feel like this was a good trade-off in that we get to use SSZ for most of the things, but we also don't have to rewrite a lot of stuff in clients to let them import.
So this is, I think perhaps the reason I don't see the future is I have always imagined this to be something that sits external to the clients. And so you would have some little thin thing that knows how to download a torrent and knows how to do some data manipulation. And you would use that to do the bulk file download. And then you would just have a button in there that says export to Nethermind or export to Geth or export to whatever. And so, and the reason for that is because specifically so we can avoid having to convince clients to let us integrate into them. We can just build this entirely isolated from the clients and just say, hey, we're done. You can now sync Geth by running this little script or whatever, this little tool, hit a button, and now your brand new Geth client is synced up to January 1st, 2021 or 2022 or whatever.
Just
So we
from
can
my
still-
understanding, one question there. To do, if we were doing what you described, to do the, press the button and import into Geth, you'd need some new support for that on Geth side, right?
Well, most clients support this functionality, this like import subcommand that lets you import a like
Oh.
directory of RLP blocks.
Oh, okay. I
So
didn't know that. Okay,
um,
that's helpful.
we can already probably do it like Micah is saying. This is, I guess, another question, like exactly how is this integration going to go? I would say one client does have to have 4.4s integrated because we want to be able to export the historical data into these structures, and we want to be able to verify. I think verification is important because whenever, some entity says this is the, this is the root of this section of blocks, like we should have people who can, very trivially retrieve them and verify them.
And you wouldn't count like just running Geth after running this import as verification, I guess. Like when you're running that import into Geth, I believe it verifies in that step, doesn't it?
Yes, but the time it takes to execute is a lot greater than the time it would take to just verify the, historical blocks. Like if you were running a full client, if
So
you're
saying
imagining this
when you
world
do
where
that-
you're, I'm
you're
just
saying
saying
that
like
when you do that import, it tries to fully verify it, whereas you want like a light verification where you're just like, hey, do these headers make sense?
well, I'm just imagining that, we create this new checkpoint, this period, like we haven't expired these blocks yet. And so we still have them locally. And this is the proposed checkpoint of those historical blocks. So I should be able to download that and then compare them to what I have locally. And so, yes, you could execute them and make sure that you're at the, the canonical head of the chain. But that's a lot more time consuming than just verifying that you are aware of those blocks.
We should try and move to like action points or things to do after the call
Yeah, that sounds
before
good.
we run out of time.
Yeah, Henry, I guess like you're the person who's really going to be driving a lot of this initial implementation. So are there things that we can do or questions that you need answered so that you can move forward? Like on our front, we'll talk with the Geth team, so we'll continue like working on some of the more like philosophical questions about, what is okay to distribute, how to distribute data. But I want to make sure that you're unblocked to move forward.
Yeah, thanks. I think I am. That this has been helpful, and I think, given that the immediate first step is writing out or coming up with a first Roman layout, I can get started on that right away. And then I guess I'll update as it moves forward, and there's something to get feedback on.
Okay, great. We've got 8 minutes left. Other things that we should talk about. I see Vitalik's here. Is there
So-
anything that you want to go ahead, Alex?
I was just gonna say, like, in parallel with implementation work, we can like, start drafting some kind of EIP-ish thing. Because like the more concretely we can write down what we're trying to do, the more we can say, hey, Geth team, hey, Piper, like, how does this sound? And the more specific, the more productive we can narrow down to a specific design. So
So you
that's
think we
something we
should
should also
draft
be
an
doing.
EIP that actually describes the distribution of the data and like what the format of that data will be in addition to like what we have with 4.4s? Those should be separate things, or
Yeah, I guess, yeah. Maybe like it's not quite an EIP, but just like writing down like our thinking so far and like documenting that process for other people.
Different
Because like it's like, I mean, I'm
EIPs
pretty sure
for-
people said like 4.4 as written like would never ship, right? Like I feel like maybe George Colvin or someone said that. Like I just feel like there's like
Do you agree with the separation as proposed before, where we have execution, or sorry, we have the formats, we have the import export, and we have the distribution?
yeah, that makes sense to me.
Okay, then let's split that into EIPs then.
Cool. So I would say, whatever format you want to write this up in, Henry, as you like work through this, then we can like work together and put that into something that's like an EIP. So that would be the first step for the actual data format, and then we'll, the distribution format is something we'll continue working on and discussing.
Yeah, sounds
Just
good.
out of curiosity, is anyone here right now opposed to torrents or think that's a bad choice? Or just people in?
it's like probably a great way to start. Like maybe we like get 6 months down the road and Marius is like, we can never do torrents, and then we have to tweak it. But if we start now thinking of it as this like modular bit, right, to this design, then we'll swap it out when we need to.
Yeah, I guess one thing that was not added on the roadmap that, is another thing that's farther out, but some sort of like bridge client that allows you to like maintain the archive functionality. That's, I think this is something that's, at least 18 months, 24 months away, because I don't think that Geth is looking to remove any consensus code, in the near future, but it is something in the medium to longer term that they will want to do. And I do think that it's pretty important that we like maintain the ability to generate all historical artifacts. So that's something to keep considering. I think like, it's not really a theoretical problem that needs a solution. Like it seems relatively clear, like we just run certain client versions and have some sort of, multiplexer that is able to route requests to the version of the client that understands the information. It's just going to be an engineering challenge. All right. 5 minutes, is that it?
I can easily fill the time. I was trying to respect the goal of actually getting out of here on time.
Well, you've got 4 minutes if there's something else you wanted to discuss on 4.4s.
I would love to go down the rabbit hole of SSE all the way down. Like I feel pretty strongly that would be a big boon long term.
You think that we should SSE the actual block values?
Yeah, blocks, transactions, uncles, everything. Like we just get so much power from being able to prove everything arbitrarily.
Right, but is it strange to just leave that as a detail for now and at least define the tree of all of the blocks, and then whatever the leaf may look like, we can change later?
Yeah, I'm okay with moving forward, just like using RLP as a placeholder for the blocks for now. In my experience, once you have a placeholder in, it gains strength the longer the placeholder sits there. And if you let a placeholder, oh, it's just a placeholder, and then 4 years later, yeah, that placeholder is permanent. We're never moving it.
Okay,
But
I do think that there is a natural shelling point for moving everything over to SSE, even if we start with RLP, because like eventually we are going to turn even the beacon block that goes into the execution block that goes into the beacon block into an SSE format, right?
So much
Okay, so
confidence.
how about we switch it around? We start with SSE for the block and do the revert to RLP if it doesn't work for clients.
Yeah, I'm okay with that. Just flipping sides here. The advantage to, of course, to RLP first is that there's less engineering work. Like we already have decoders and encoders for RLP blocks. So you can just copy and paste.
Mike
We have
wasn't
for
kidding that he
execution
could kill his
payloads as
time.
well.
I mean, don't we have
We should just
the-
all leave and let Mike argue with himself.
This meeting would never
I'll
end.
keep
if
the
you allowed
recording
that.
on. So after the merge, I mean, we're going to be able to prove things about historical execution and payloads, like with the granularity of SSE anyways. So is it that
Why?
big of a boon?
How?
I mean, there are the historical like accumulators in the beacon
Like
state.
if I want to say, if I want to create a witness of this transaction occurred in this block, and these are the transaction, or like, and this
Yeah.
state entry.
I think
was
the
mutated, or
transactions
that
are still
was this.
RLP encoded though, but you could prove a certain transaction.
You're saying I can prove a transaction hash? Is this because with the merge, are they switching the block header to SSE?
Yeah,
still
well, at least
RLP?
there's a representation of it, and then transactions are still opaque. And the idea is in another fork or two, we'll sort of switch fully.
Right. Like I
Okay,
think
so-
with the merge, what happens is that the transaction, the list of transactions becomes SSE, but each transaction is still opaque, and then the receipts are still opaque, and then obviously the state is still opaque. And I guess we want to eventually moving the receipts over to SSE should not be super hard, but then eventually we want to move transaction internal structure over.
About that, moving receipts to a format that can do proofs over those receipts would be really, really useful for layer 2 protocols.
Yes, I was actually having some discussions about cross layer 2 bridging, and one of the big hurdles that actually came up was basically the fact that if you want to prove something in one layer 2 to another layer 2, then like first of all, there's stuff that the layer 2s haven't done that they really should do, like make the L1 block hash accessible as an opcode. But even going beyond that, like it requires these proofs going into a receipt that contains the L2 state root, and then you have to do the same thing inside of the L2. And the thing with rollups in particular is that with rollups, execution becomes much cheaper, but data does not become cheaper at all. And so Merkle proofs could easily become like the biggest cost factor if secure cross rollup stuff becomes the norm. And so like, might it even make sense to skip SSZ and go directly into putting receipts into like either a Virgil tree or a KZG commitment? I don't know.
I can think of two more things that hurt layer 2s with the current receipts design, but we should probably focus on the force now.
I'd love to hear
Is that
more.
everything?
I think so.
I can stick around and talk about layer 2 though.
I'd be happy to
Yeah.
do that.
need
And
to
one
hop
other thing
off.
that would be interesting to talk about eventually is like the 10-year roadmap, where hopefully at the end of the 10 years, we have everything, including the execution and beacon state and receipts as part of the same structure. But I guess we can leave that until later.
Yes, so I think I really like the idea of using this opportunity. This is an opportunity to get data structures into a, for lack of a better word, more modern place. So like we've got Virgil trees instead of Merkle trees. We've got SSC instead of RLP. Like there's lots of things that if we were to start over with Ethereum today, we probably would not do the way they are. And so this is a kind of an interesting opportunity to take on that and say, hey, this is the new standard way you do blocks in Ethereum. We still have the legacy way that all the clients use, but going forward, if you're building something new, use this new data format. Of course, as I was arguing earlier, that's the more we do right, the more engineering we have to do to get it right. Like it's much easier just to do the status quo than it is to do something new. So I'm conflicted on that.
Before we dive into the future of receipts and everything we can improve about proofs, Do we want to end the recording here for forest purposes or just add it as an extra? Everyone is fine with recording?
Free bonus to anyone who's
Free
watching.
bonus. All right. So about those receipts, this is like the information about the execution output of the layer 1. This is really different from all the input information in that we rely solely on the receipt route of the layer 1 to interpret the execution as a layer 2. So this is really distinction. It's not just about data commitments, but about knowing about execution. And the problem here is that receipts can be huge. They can be larger than we can load into the EVM, making optimistic rollups, for example, really difficult. And then they are Merkleized in a way that's also quite ugly, with the Merkle-Patricia tree doing index data. Like this is the type of tree where we have consecutive leaves, where we can just simplify the Merkle structure.
So if I understand correctly, the idea here is that if we could easily prove receipts, something like a ZK rollup, where some rollup somewhere, optimistic or ZK, might see a transaction that updates a state root, but it doesn't have a way to verify that the EVM actually did successfully update that state root and it wasn't just someone lying, right? Like you can send a transaction with a state root update, but that doesn't mean it was accepted. Whereas the receipt actually says, yes, this state root was accepted on layer 1. And by having access to that receipt in some rollup, you can then prove that and say, yes, we verified that
so
this was actually
the only
accepted.
way to not have to re-execute the same layer 1 process is to just prove the receipt. And that's quite inefficient right now, and nearly there are edge cases for optimistic rollups that make it even more difficult. Receipts can contain many logs, and instead of Merkleizing the logs, for example, they're all just concatenated, encoded, and hashed in one go, which sounds efficient, but for layer 2s and these protocols that want to interpret individual logs, it's really difficult to prove.
Right. So if we had SSZ and Verkle trees everywhere, you would be able to get a nice little witness of a single log. Potentially, I mean, if you really wanted to go all the way, a single data point from a single log, and just say, hey, I'm going to prove to you that this log occurred with this as parameter 3 or whatever. And you can be confident in that just with the witness and a single like block hash for example.
Exactly. That would improve the usability of layer 1 information for layer 2 by a lot.
Yeah, it's really compelling. Like I said, like if engineering was free, I would 100% be pushing this super hard and say.
I mean, we do have resources at Optimism for this type of stuff. I'm sure other layer 2s are interested in such changes as well. Anyway, maybe we should just open an EIP or something for this as a separate thing. And then to work back to the SSE discussion, this is one example where block information in a different shape or different commitment type is really useful. I'm sure there are others, and if you know of any of these, you should aggregate those, and maybe we can include in the same EIP, or at least add this to the EIP discussion about the format for the historical blocks.
I mean, I'm guessing someone could make basically more or less the same argument broadly for Verkleification of the state, right? Like you want to prove some piece of the state and you just have a block hash. I mean, I've written contracts that do this, and it's hell. You're paying 600,000 gas just for the proof, like alone, not even valid. Just getting the proof on chain is 500,000 gas. And if I understand correctly, a Verkle proof would be way smaller.
Maybe Vitalik has the time to comment.
So what was the question again?
Whether or not we should just directly skip to Virtual trees for logs and receipts and such.
Interesting. It feels like something worth considering, right? But I also think that maybe we should not commit to that decision until like we do have some broader discussion of like what does the end game here look like. Because I guess like the thing with SSD, right, is that if we just move things to SSD, then like they become an SSD thing along with all of the other things that are in SSD. But the thing with Virtual trees is like basically it would be nice if possible, like if we start moving things over to Virtual trees, like if we want to just standardize and say Virtual trees are where everything is going, then there's obviously a lot of benefits that come with that. But then there's the question of like we want to make sure that we standardize on like the same sort of structure as we're introducing in other places like in the state, just to make sure we don't accidentally like create two slightly different implementations and like blow up to like 4 different kinds of structures instead of 3.
Right.
Yeah,
You get consistency, simplicity with SSE, and
Yeah.
you get more future compatibility with Virtual trees
Exactly.
at the cost of this longer
Right.
experimental period.
I guess was thinking like what would need to be standardized with Virtual trees? Probably the main thing is that in a Virtual state tree, like we have this thing where the keys get assigned randomly, but in one of these Virtual trees, it would be like the keys would be assigned
If
sequentially,
they're
I
not
guess.
random, then it's as opposed to just the case G commitments or
Well, it's not
Virtual trees switch
case G
to,
anymore.
yeah, exactly.
Yeah, it's not
they
case
switched.
G anymore. It's bulletproofs. Oh, one other question is, do we have an upper limit on how many Virtual or how many receipts or transactions there can be in a block? I guess.
Gas limit, I suppose.
Right.
Yes,
It would be nice if it
any
was
hard
arbitrary.
limit.
right.
So for receipts and transactions, they're currently like we store them in Merkle trees, but if we switch over to SSZ, is that necessary? Like, doesn't SSZ handle lists better? So like we
It
don't
does,
need
yeah.
to store them in
All
a tree at all.
There are 2 problems I currently deal with. They would already be solved with SSE here in the case of receipts, but I like future compatibility as well. So, I mean, if there was a way to verify these Virtual commitments or these kind of vector commitments, whatever Virtual trees are built on top of at this moment, if we had that in the EVM or as like ready libraries for outside of the EVM as well, then I think we're good to go and just directly skip there. Then we can skip SSE.
So sorry, so you're saying if we had all the infrastructure for both, you would prefer to have the receipts in a Virtual tree rather than just an SSC list, is that correct?
Yes, I mean the layer 2 will eventually have to verify it in the EVM or outside of the EVM, and in neither of those places we have good tooling for Virtual trees right now. And for the case of SSE, it's just a matter of using the most popular hash function with concatenation of 32 bytes and 32 bytes, and that's it. The Merkleization is really simple.
What's the advantage of the Virtual tree for just a list of receipts? Like, why would you want that if you had all the tooling?
I suppose we can virtualize the home block at that point. It would be good for ZK rollups. For the optimistic case, I don't think there's any special benefit. Maybe proof size.
Why does it help the ZK rollups to have a Virtual list instead of an SSE list?
Because hash functions are expensive.
Right, the Virtual tree is deliberately designed with a specific curve, which is like the exact same or the field modulus is the order of VLS 1231, which makes making ZK snarks over it really easy.
I see.
Anyway, I have to
we
drop off in a
lose that.
bit as well.
And we lose that feature if we just do an SSA list, and so therefore, what would have been a very easy proof to generate is now a more expensive proof. That's accurate.
I mean, the current design is crazy expensive anyways because of the RLP overhead, all the logic gates around encoding the RLP before merkleizing it each step. SSE is simple, but still expensive because of the hash function. And then vertical trees or any kind of vector commitment in that area of research would be an improvement for ZK layer 2 usage.
Just a quick pie in the sky question. Does it make sense to vertical tree the entire block, just like from the header down?
I wouldn't call it a vertical tree.
Yeah, I mean,
But
I
yes.
think like eventually, like I think if we standardize and say vertical trees are the thing that we're doing, then like it'll make sense to move beacon blocks over to it and move like everything over to it.
Do we still, with vertical trees like that, do we still get the ability to do like proving just arbitrary pieces?
Yes.
Like we can with SSE?
Yes.
Okay.
The proofs for arbitrary pieces become even shorter.
So now I'm rolling through my head. Well, why are we stopping by SSE on the way to percolization of all the things?
I mean, I
why do
think
we have this
for
intermediate?
yeah, I mean, I guess one argument for it is that like if we at least shove things into one format, then it becomes easy to upgrade that format to a better format all at once.
Not sure, but like right now that format is, I guess that format right now is RLP plus.
Right. Well, right now we have
right?
right now we have a really complicated mix of, or we're moving toward having a complicated mix of what was it? There's some RLP, some SSZ, some Verkle, and some BLS 1231 KZG.
So note
Which
here
is,
that
not
SSE
ideal.
also defines encoding. So once we move all the encodings over to the same system, then we can redefine the merkleization or the verticalization later. But at least that part will be consistent. And right now we are in a really messy situation where the encoding RLP is part of the Merkle-Petitjean tree and thus also still a dependency. If we were to move everything to SSE, we would have consistent encoding everywhere. And then we would not have special encoding rules in the merkleization. And then ideally, we just swap that out for vertical trees.
Okay. Does my little roadmap there sound like something that is hypothetically reasonable and align with what you guys are saying?
Merkle at the leaves is a little bit vague for those that are out of the loop. But yes, I guess. I mean, you mean
Okay.
merkleize the byte list, the opaque data there in like
Yeah, it's
the
like
now situation.
Merkleize the state, Merkleize the transaction list, Merkleize the receipts list. I guess inside of that, technically, you've then got RLP. So it's not the leaf most thing, I guess, technically is RLP.
Right. Yeah, so, okay, we have these three EIPs for force, one for format, one for the import-export functionality, one for the distribution. At the very first, we have this discussion that's relevant. There, we should try and see how SSE execution payloads work, if it's worth trying, because it improves the proof situation of our historical block data, which could help projects like that from Piper. And then we can have that or not. Anyways, we have the merkleization of SSE on top. And we could look at verbalization here, but I think for us it's out of scope. Does that sound right?
Yeah, that sounds reasonable.
Yep.
Okay. Happy Tuesday. I'm leaving now. Let's go. I'm host. You want to continue the call? I'll make Mika host.
Now I'm just gonna stay in here for the next 7 hours arguing with myself. I'll be all alone.
Bye, everyone.
See you guys later. Thanks.
Later.